Okay, hey everyone. We are going to talk about tuning GenAI workloads on Kubernetes. So what works and what doesn't? Let's go to the next. So yeah, just to introduce ourselves, I'm Ishaan. I used to work at Microsoft. I worked on Kaito, which we're going to be talking about. I left Microsoft about 5 months ago, and now I started a company, Omnara. We run coding agents on your phone, and I'm the CEO and co-founder. And this is Brian. He's a senior engineer at NVIDIA, and we're going to be, so let's continue here. So first I want to just give some background for what we're going to be talking about. So let's talk about generative AI. The first thing that I want to talk about to set the stage is what are the implications of running LLMs, okay? Model sizes are getting really, really big. Okay, last year, I remember GPT-4, for example, was about 1 trillion parameters. It was rumored to be about 1 trillion parameters. And GPT-5 is 10 times the number of parameters. Okay, so model sizes are getting massive. And as models get larger and larger, the amount of tokens you need to train them actually goes up exponentially. Okay, and dealing with such large models, this is very expensive, it's very costly, it's a resource problem, and essentially why we're all here today is it's an infrastructure problem, okay? And we think that Kubernetes is the best way to solve it. So that brings us to the next topic here, why run LLMs on Kubernetes? Okay, there are hosted solutions out there, right? There is Azure ML, there's AWS SageMaker, there's a bunch of startups building hosted solutions for serverless endpoints. The reason why you'd want to use Kubernetes is if you want to own your own infrastructure, right? You want to own your own data. And so what that means is, like, let's say you want to use a custom ML framework or serving engine. You want to use DeepSpeed or Onyx or NVIDIA Trident, or you want to set quotas and permissions or networking. So any sort of advanced use cases, you want to own your own infrastructure, right? On top of that, the cherry on top is that the community is like really, really supportive right now. I mean, the tooling is super robust. I mean, Hugging Face is not only providing the models for you to download, but you also have, I mean, all the libraries to get up and running. So it really is like the best time ever to run LLMs on Kubernetes. That said, I think no one here is a stranger to this. Kubernetes is hard, okay? Even for experts, Kubernetes is hard, and AI is hard. And the reason for that is, like, you got to maintain these massive model weights, these massive model images. You have to build and host custom, images for your workload. You have to provision the GPU. You have to set up the drivers and the libraries, the networking. Also, it depends on what type of workload you're running. If you're running inference versus fine-tuning or RAG, they all have different parameters. And then the last thing, which we'll talk about at Skyhook too, is the operating system itself. You have to configure the OS settings, because this isn't like, you're not running a web service anymore. These are hardware-intensive workloads. Okay. So that brings us to what we've been working on, Kaito and Skyhook. So first, for context, what is Kaito? Kaito is not a platform, it's not a service, it's a CRD. It's literally, it's just a controller, right? Kaito is a controller for streaming AI for streamlining the deployment of AI workloads. Okay, so we make it as easy as possible to run an AI workload on Kubernetes. Okay. What does that look like? So this is Kaito in a nutshell here. It's literally just 10 lines. The whole CRD, you can run an AI workload in literally 10 lines using Kaito. And there's like two main parts of this. Got all these animations on the slide. Okay. Yeah, so there's like two main parts of this, of the CRD here. There's the SKU. So that is the machine that you're going to be running on, and it's vendor agnostic, so supports Azure, AWS, any cloud provider. And then you have the actual model that you want to run. So we use VLLM under the hood. So any VLLM ID works there for the model preset that you specify. And then Kaito goes ahead and provisions the GPU, the drivers, the CUDA version, PyTorch, and it runs your AI workload. Runs your AI workload for you, and it exposes an endpoint, so a load balancer or a cluster IP endpoint that you can hit. And yeah, I can't emphasize enough. It's just so simple. It's literally 10 lines, and you got a whole ML deployment live. OK, this is what it looks like under the hood. So you specify the workspace CRD. And then there is, we use Carpenter to provision the node, another open source technology. And that's what's actually creating the node. So all you do is specify the workspace CRD, the workspace CR. That creates a node, like a machine CR. And then that goes ahead and creates the VM. And then we pull the inference image from MCR. And the weights themselves are an OCI artifact. Okay, and that gets pulled in as an init container. Those weights get pulled down. Okay, now I'm going to show you some examples. Like this talk is not meant to be like in-depth ML concepts or anything, but this is just a high level to show you how you'd run different ML workloads in Kubernetes here using Kaito. So this is inference on top, but then you have adapters below that. I'm not sure how familiar people are with adapters, but adapters are just fine-tuned set of weights. So these are LoRa adapters, meaning that you can actually merge them with the base model, and then you get a fine-tuned model. Okay, and you can specify that easily with Kaito, and then those adapters are loaded as init containers, and there's a shared volume, which then they get merged into the base model, which is Falcon here. Yeah, and if you want to talk more about like these ML workloads, happy to do it afterward. This is an example of running fine-tuning on Kubernetes. So with Kaito, so you can specify the model just like before. And again, it's like it's built to be as easy as possible, right? So I mean, what is this, like 12 lines? So it's easy. So the method you specify here, you can specify LoRa or QLoRa for the fine-tuning method. And then you do have a place to set your hyperparameters for your ML job. So that's in a separate config map, which you specify here. And then you specify your input data source and your output data source. Or sorry, your output for checkpoints, for model checkpoints. There's a sidecar container, which is uploading the model checkpoints to whatever volume source you specify. And then the init container is what's downloading the data set for fine-tuning. OK, really quick, one more example. This is RAG. Some of you, I'm guessing a good portion of you at this point have at least heard of RAG. This is an example of how you'd run a RAG deployment using Kaito on Kubernetes. So again, super simple. You specify the vector DB. You specify the embedding model that you want to use. So we use any Hugging Face embedding model. And then the inference service, which could be a Kaito deployment itself, or it could be your custom serverless endpoint for inference. So yeah, super straightforward. And now I'm going to hand it off to Brian to talk more about Skyhook.
Thanks. So yeah, Skyhook. It's also an operator, just like Kaito, but it's for modifying the host OS declaratively. So can I get a quick show of hands? I got a couple questions here. Has anyone ever wished a daemon set could cordon and drain before doing something and then uncordon the node? All right, got a few hands, okay. And how about this? You ever wish you could just update a package on the OS or some kernel setting without having to redeploy the whole new OS image? All right, quite a few hands for that one. Cool. Well, these are just a couple of the problems that we built Skyhook to solve. So I'll just share a little bit more here. So yeah, here's a high level of what Skyhook does. So we're going to monitor the nodes and pods and our custom CRD, and we're going to react to any changes that we see on the nodes and push those nodes into the declared state from the CRD. Additionally, for monitoring purposes, we also collect a lot of events and telemetry throughout this process. So real high level here, hello world Skyhook. This is somewhat contrived, but follow me here. So we support node selectors, so if you only want to hit, let's say, your GPU nodes, you can select those here. We call them packages, so they're kind of similar to like a package manager for your whole cluster was kind of the idea. Anyways, a package is a container, actually. So the first init container in our pod is actually just the contents. So it's the requirements for that package just needs CP and make dir. And we're going to just use CP and make dir to copy all the contents out of that onto the host file system. And then the next two pods that run are our agent pod that then take the scripts you left behind and some metadata that are part of that package to do whatever that package does. And in this case, this is our shell script package, which lets you execute arbitrary shell scripts, which I know sounds dangerous. It is, but it's useful for proof of concepts or hello world or a hotfix. So anyways, in this example here, we have the apply lifecycle here. So at apply time, we're gonna cat some content or echo hello world into a file, and then every single lifecycle has a check as well. So here we're actually checking that file exists, and so that way you can make sure that the things you wanted to do actually happened. And so that's a core tenet in Skyhook. Let's see here. So here's I had another guy there. So here's a more useful example. Let's say you want to configure huge pages. And I guess take a step back. Huge pages is a feature in the Linux kernel. The default settings for your pages are pretty small, especially these days. So if you have a memory-intensive part of your application or your workload, you might see some improvements by setting huge pages. So like maybe you're copying a lot of data off the network. Set up those huge pages so that the kernel has a place to put that data. Just one example. But huge pages is a GRUB setting. So to change your GRUB settings to take effect, you need a reboot. And so that's we're gonna show you some of the power here of Skyhook. So here, we're actually, so if you're gonna reboot, you're gonna wanna coordinate and drain. So this is where I was getting back to, like, daemon sets really don't help you there. So here we're specifying our made up workload, Kaito here, our app Kaito, as a golden workload, as I like to call it. So we're gonna first wait for any golden workloads we're gonna first coordinate the node, wait for any golden workloads that are on there, and then do the drain. And after that, we're gonna then do the work, which we're gonna configure huge pages. Our tuning package here kind of covers up what that is, so it makes it really easy to do that. And then the last thing is we're going to do the reboot here. And part of the package definition here is to tell it that there is a reboot. We also support service restarts, so if you want to restart like containerd or the kubelet, if you want. I guess two things not shown here is we also have a upgrade and uninstall. So the uninstall is actually pretty useful for this. If you're hunting for tunings, you can put on huge pages and then take them off. You don't have to like get a new node. Save you some time. So yeah, that's Skyhook.
Okay, now we're going to talk about the experiments. So for some context, Brian and I met a year ago in the hallway tracks of KubeCon Salt Lake City, and we became good friends. And over the course of a year, we talked about what we were working on, and Brian was obviously working on the configuring operating system settings and OS settings on Kubernetes, which I had no background in, I took a class in college, like everyone does, but I had never experimented with that on Kubernetes. And likewise, Brian hadn't experimented as much on running LLMs on Kubernetes and AI on Kubernetes, so we both were like, this is really cool, we have a hypothesis that we can combine both of what we're working on. It could lead to faster AI and get better performance out of our models. So that's what we'll talk about. So we set up a framework for testing this. It's an open source repo called Deep Tweak, which we'll share at the end of at the presentation. You can probably just, yeah. So we ran a Kaito deployment. We collected benchmarks on its performance. Then we use Skyhook to change OS settings, operating system settings, and then we collect the results of those experiments and we compare them to the baseline. And yeah, we did that a few times. Yeah. Oh, yeah, and this is an example of one of the experiments we ran. We had some ideas on hunches of what would happen. Of course, we weren't sure. But this is we didn't know everything up front, but this is an example of something we tested out. So we changed VM swappiness. So swappiness is the OS to disk swap, the disk to RAM swappiness. We tested changing the CPU isolation, so like to minimize interrupts so that the workload wasn't getting disrupted as much. And then we played around with some network settings as well as file descriptor settings. And then we saw what happened.
Yeah, our results actually weren't great, which so I mean, we did have 3 here that had significant p-values, meaning they did have statistically relevant outcomes. They were negative, however. The other 2 were actually just noise. And you know, it's funny is, in hindsight, this makes a lot of sense. These workloads that we chose were GPU bound. So I think one thing was after doing this, we're like, well, we probably should have profiled these to begin with, but that wasn't where we started with this thought process. But anyways, there's quite a few Linux parameters in the thousands that you could do something with. Not suggesting, the big thing, I guess, you should profile ahead of time before just jumping into this. That's kind of what we learned here. But I think some additional things that we didn't have time to look at. We focus most on throughput. Latency is pretty important depending on if you're doing inference, for example. Stability, like reducing outliers and variance. I think probably one of the most important things that you can get with OS settings is actually reliability. I think everyone agrees that a crashing job will definitely affect your throughput or your latency. And we were strapped for hardware, so we actually didn't get a chance to try anything other than a single instance for any of this stuff. So there was no distributed inference or training that we tested, so we weren't able to really have. I think those all bring in a lot of network, which then bring in a lot of I/O, which then expose a lot more kernel involvement in your workloads. And similarly, we had one variant of hardware, which is A100s on AMD 64. And I guess something else to note that a lot of the CSPs are VMs, so VMs aren't nearly as tunable as bare metal. There's a lot of PCI and CPU type settings that really don't do anything in a VM. And nowadays, ARM is becoming more and more popular, and that's a whole new architecture, whole new set of Linux parameters in different hardware. So a lot to think about when doing this activity. But again, profile ahead of time. So yeah, I think the big takeaway when we started this, besides that we didn't find anything, performance improving anyways, was just how easy it was. We met up, and I think 10, 15 minutes later, it was a real short Zoom call. He's like, all right, I got this, and just started doing experimentation. So to me, that was just ML engineers, not SRE type folks can actually, with these simple tools now, actually start doing this kind of searching. So that was a big takeaway. I didn't really get a chance to cover it. There's a lot of other use cases for Skyhook that led us to creating it. So security is a big one. We use it for custom SSH agents, threat detection scanning, CVE scanning, things like that on the host. We also use it for configuring, like I said, some of these settings. Huge pages is a big one. And that comes, I think EFA is a big thing. So if you're enabling EFA, you need to enable huge pages. It's just one example. And then the biggest one, I think, we operate a lot of clusters, and they're for different use cases. And so we didn't really want to manage a custom image for all these different use cases. And so we have actually just a base image, and then we use Skyhook to come in and layer on tweaks for the specific use case. I think a cool thing too with the uninstall piece, part of Skyhook is you could come in for like one training, put like one OS config down, and then the uninstall can come in and pull it back out, and then a new job can come in. We built it for that. We haven't used it for that yet, but anyways, we have several packages now, and we're looking for more. I didn't talk about these today, or there were no examples of this, but we have a kdump package. So if you're having kernel crashes, you can use Skyhook to enable kdump and get a kernel crash. And the tuning package I showed, we've actually replaced it with one called TuneD, which is, it's actually a Red Hat project, and they had way more features for tuning. So there's a bunch of tuning profiles that they provide that we can come in and layer in with Skyhook, or you can make your own custom TuneD profile. So that's pretty cool.
One thing I just want to hop in, we're going to talk about the future now, but before getting into that, just to reiterate, yeah, we only had one GPU on hand that we're using to test this. So it was only one node. And for the amount of, like the size of the model we're running, the CPU only really gets involved when you're loading the data for the specific workload we were doing, was loading the data and then moving the data to the GPU, right? That said, there are plenty of workloads where the CPU is more involved. If you're pre-processing any of that data, that's all going to happen on a CPU. If you're any sort of network settings, just like what Brian was talking about, I just want to emphasize that the workloads we were running were rather limited. We didn't get to test more extensive things. But yeah.
Yeah, so future, Skyhook, I'm still working on it. We open sourced it earlier this year, so it's actually kind of a newer project. Yet this year, we hope to release deployment strategies and node compartments, and an SRE tool to make actually operating this thing a lot easier, so you don't really need to know how it works under the hood if you say, like, redo this on that node or things like that. We hope to get to in the spring container attestation, and those same node compartments that we're about to release, we're thinking about using those for some security features, like allow listing certain containers to run on those nodes. So, i.e., like, I only want to allow shell script to run on my control plane. Maybe that's a terrible one, but so yeah, that's kind of where we're heading in the near future.
Yeah, and last slide here. We've been talking all about orchestrating AI workloads. The next evolution of this is orchestrating AI agents. That's the next step, and that's what I've been working on. And these past 3 months, so we let developers control their AI agents from their phone. So you could launch your agent from your laptop and then pick up from your computer. We launched a couple months ago. We have 5,000 developers using us. They've launched over 30,000 coding sessions now through Omnara. And I think as AI agents start to handle more complex and longer running tasks, these sort of tools become essential for every engineer building with AI. And pretty soon that'll be every engineer on the planet. So if you're handling long-running AI workloads, I'd love to chat about being a design partner, or just check out omnara.com. We're all developers here, and let me know. You can grab me after the talk. Let me know what you think. Cool. And now time for QA.
There's a mic back here in the center.
All right. First of all, good session. Thank you. It was fun learning what you did in this quick time. One question is on the first project you talked about. You mentioned instance type, only one specific instance, but you also mentioned you are using Carpenter. So how does it work if you are specifying in your Kaito itself, right? How does it get translated into Carpenter, which is selecting maybe hundreds of instances?
Yeah, so the Kaito CR creates a resource claim. So it creates a Carpenter, it uses the Carpenter CRD, an API to create GPUs. Does that answer your question? Or?
It does kind of, but what I felt like you are already locking the instance type by specifying the instance type, then Carpenter doesn't have enough to do anything because you are already telling, give me this type of instance.
Yeah, I think the big benefit of using Carpenter here is that we're able to use any cloud provider. It gives us like one standardized API to use.
Makes sense. All right. Second question was, you guys mentioned you can reboot the node. Have you considered looking into something like KEXEC rather than taking a full reboot? You talked about physical machines or bare metal. Generally, BIOS, post tests, they take time. And we are talking about making AI fast. Have you thought about using KEXEC instead of full reboot? If not, why not?
I'm not exact. No, we haven't thought of that. Okay. I'd be happy to hear more about that after this.
Okay. All right. Thank you.
Hello. Kaito versus like Kubeflow trainer. I'm struggling with the differences.
Oh, for sure. Kaito versus Kubeflow was your question?
Yes,
Okay.
please.
Yeah. Kubeflow is another solution for running AI workloads on Kubernetes. The main difference, especially with the people we talk to, is just how much more concise Kaito is. It's a lot simpler. We also host the model weights for you, so it's meant to be like a turnkey solution, like plug and play. You can definitely use Kubeflow, though. I know there's like a lot of very advanced use cases for using that. Yeah. Okay, anyone else? I've been doing this informal poll, which is interesting. I've been asking people, are they using coding agents in general? I'm curious, by a show of hands, how many of you guys use a coding agent? Okay, yeah, nice. Okay, I was surprised, a lot of people are using Copilot, I see. I think because the company policies, they haven't started dabbling in Claude Code and Codex. Anyway, thought that was interesting.
All right, I think we're at time. Thanks, everyone.
Thanks, guys.